and welcome to our first video regarding our discussion or video tutorial for our subject heat and mass transfer. I'll be discussing about introduction to heat transfer and conduction, which is the first mechanism of heat transfer. Okay, so what is heat transfer first? Because we need to define this heat transfer because we're always talking about this matter. So ngayon, heat transfer, from the word itself, it means the transfer of heat. So in a sense na we're considering the resistance as well as the driving force. Now, it is easier to understand this when we have a background knowledge in thermodynamics. We say that in the 0th law of thermodynamics, we know that if an object A has a temperature of, let's say, T1, and it is in contact with an object B which is in temperature 2, after some time, they will have an equilibrium temperature. And in a sense, the heat transfer also works the same way. That's why we have different kinds of mechanism. Okay, and in general, our Fourier's law states that the heat rate or the heat flux of certain material, it is directly proportional to the temperature gradient along that area or along the line of heat conduction. So it can be written in a simpler term. For example, we want to express it in an equation. So in that case, if we say that heat, so we represent heat as Q, so that is Q, and then the rate of heat flow per area, this is equal to the temperature gradient. So if we're talking about gradient, we're talking about the difference of temperature. And in differential equation, we can represent this as dt instead of using delta t, since tayo naman ay may background na sa differential equations. So let's just use dt. And then, along the line of the area where heat is transferred, so meron tayong difference length, which we will call dx. Okay? So, paano ba natin siya ma-imagine sa isang material, no? So let's try using a slab, which is one of the most common material that we use to explain this Fourier law. So for example, we have a slab here, and then it is a 3D. Okay. And for example, I have here, let's say, temperature 1, and then outside that slab I have a temperature 2. So let us assume that they have a different temperature. So therefore I have dt since I have a temperature gradient, since T1 is not equal to T2. Now, the heat, for example, if T1 is lower and T2 is higher, then the heat from this higher region, it will flow to the colder region because, as we say it in Filipino joke, sabi natin lagi ay saraduhan ng pinto kasi lalabas yung aircon. But the truth is, we have to close the door because heat will come in, simply because the environment outside is hotter than the environment inside. So anyway, wala man tayong aircon. So sila yung aircon natin sa joke. So if T2 is higher, so let's just assume that this one is higher and this one is lower. So in this case, heat will the heat will travel from this area here going to that side, and this heat So, it will pass through this slab. And of course, this slab, syempre, meron siyang tinatawag natin na resistance. Okay? And yung resistance na yon, somehow it is given by the thermal conductivity of the material. So in this case, what completes our equation, or the Fourier equation, is what we call the thermal conductivity, which is usually represented by K. Now, sa Paris handbook nyo, meron mga thermal conductivities, but some problems already indicate the thermal conductivities of the material, and lucky kayo pag ganun yung problem. But if not, then you have to excavate your Paris handbook to find thermal conductivity. And I think if I'm not mistaken, it is located in the hidden mass transfer section of your Paris handbook, whichever you use, 7th, 8th, or 9th edition. Okay, so that's it for the general equation for the Fourier equation. So Q over A equals K dt over dx. So this only means that it gives us the general equation of the rate of transfer, meaning this is the driving force, which is the temperature, and then divided by the resistance. The resistance is the resistance offered by the material itself, which is dependent on the thermal conductivity of the material. Okay, so that simply introduces us to to heat transfer. And it makes sense kasi when we talk about heat transfer with regards to thermodynamics, heat transfer and thermodynamics, they all talk about heat, okay? But the main difference between heat transfer and thermodynamics is that in thermodynamics, we are concerned with systems that are in equilibrium. So, kaya meron tayong first, second, third law of thermodynamics, because we're concerned with how this energy or this heat changes from paano natin siya i-convert. For example, even yung potential energy to kinetic energy. So, those things, napapag-aralan siya sa thermodynamics. But in heat transfer, we're basically inclined with the discussion about heat transfer in a non-equilibrium state, meaning it changes with time, as well as yung mga we're always concerned with the rate of heat, of the transfer of heat, because in thermodynamics we're concerned with the amount, usually the amount. For example, how much work is needed, how much calories to burn this something like that. But in heat transfer, we're focusing our lessons in finding the rate of heat transfer and probably the final temperature, or for example the power rating, or those heat that will involve time. Okay, so in that case, so this is just to introduce to you the general equation of our Fourier transform of our Fourier equation, which we will be using a lot, especially in conduction. Okay, so before we begin with conduction, let us just first introduce the mechanisms of heat transfer. Okay, and there are three main categories of heat transfer mechanisms. So the first one is elementary pa lang, inaaral natin So the first one is conduction. So siguro magbibigay na lang ako ng exact or more detailed definition with regards to conduction, but in general, conduction is the movement of not movement, but the transfer of heat through a medium, solid medium usually, but heat can still be transferred in medium like liquids and gases. But generally, we're considering solids here. usually. Okay, and then number 2 we have convection, or in your module it is written as convective heat transfer, because it is there are a lot of cases of convection, so it must be generalized, but for the sake of writing it easier, let's just use convection. Okay, so convection, and then finally we have the radiation. So radiation, it's not limited with what makes us vulnerable to cancerous cells, no, but somehow it is related, but we're dealing with the heat that can be probably felt or emitted through radiation. Okay, so with that, let's proceed with the first, which is the let's proceed with the first, which is the conduction. Okay, so before anything else, before we can solve for conduction, we need to understand what is thermal conductivity first. Okay, so thermal conductivity, which is usually represented by K, is conductivity. Ito yung property of a material, something like density, which is, intrinsic sa mga material natin. So, kahit gaano pa yan kakapal or kahaba, thermal conductivity will still stay the same. Okay, since this is an intrinsic property. So, remember, your intrinsic property doesn't change with the amount or the size of the material. So, thermal conductivity is the property of the material in which kapag mataas tong value nito, so the higher the thermal conductivity, so the higher the ability of that material to conduct heat. Let's just probably use the higher K, so the higher the ability of the material to conduct heat. So something like that. No. And of course, the thing is, if it is lower, then it has a lower ability of conducting heat. And that's why we have insulating materials. They have low thermal conductivity. That's why they're called insulators. Okay? Now, thermal conductivity, we have values of thermal conductivities in your Paris handbook for liquids, gases, and solids. Now, as we go on our lessons, sa kanya malalaman kung saan siya nakikita. Just to make this video short, let's just focus muna on solids, okay, and how we use this as our basis in solving problems. Okay, so let's try deriving the equations that we use in in conduction. Okay, I'm sorry. So the only formula that you have to remember is the Fourier Equation. So with that, let's have this Q over A equal to this is equal to K, then the temperature gradient over some resistance. Okay, and then if we are talking about slabs, so if we're talking about a slab, so we can just simply define the area as the this one is a slab, and then the area here is this one, the area here. Okay, and then this is our X, okay, which is the thickness of the slab, but we are concerned with the X, meaning it is the difference. So for example, we set this one as X sub 1, then we have here X sub 2, okay, and then we have here dt, so we need to set the outside temperature as T1, and then the other side, the slab's other temperature, which is T2. So in that case, we can now probably find the general equation using differential equations, okay, by of course integrating. Now we have Q over A, which is equal to K, and then dt over dx. Now what we have to do is to simply separate the variables. So we have, let's say, Q over A dx, which is equal to K dt, and then we can now integrate the two of them, integrate both sides of the equation. Now dx can be integrated from x sub 1 to x sub 2. So what I've mentioned before, this will simply mean that you're considering the whole thickness of the slab, and then K dt, so we'll be considering the initial temperature and then the final temperature. Oh, sorry, by the way, I forgot to mention about the sign here. This is very important since we're dealing with the negative. The negative in the equation is very important because if the direction of the heat flow is towards the x direction, then, so as you can see here, it is from the higher to lower region. Then therefore, if we find the difference between these two, then it should be T1 minus T2, and T1 minus T2 will result to a negative value. So it makes sense in writing negative, so that we can simply say that dt is T2 minus T1. Okay, so you'll find it out later when we solve for the equation. Okay, so sorry, I forgot to write here the negative and then the negative one here. So let's try to integrate. Let's add some negative here. So we have here Q over A. Since the area is constant for a slab, then we can just integrate this. We have here x evaluated from x sub 1 to x sub 2, which is equal to negative k t evaluated from t1 to t2. And with that, we have Q over A times x sub 2 minus x sub 1 equal to negative k, and then we have t2 minus t1. Okay, and then rewriting this into heat flux. So when we refer to Q over A, we call this the heat flux. Okay, so the heat flux Q over A, it is equal to negative k and then T2 minus T1, and then divided by this direction or the thickness of the slab. So we have there the general equation of the heat flux in a slab. So yeah, diba? Pretty easy. Okay, so yeah, ganon siya. Okay, now, so for example, let's have a problem with this. Okay, so let's try solving this one. Okay, so sa lahat ng unit operations problem, especially heat and mass transfer, the first thing that we need to do is to analyze the problem. Okay, so let's just read this. If 3 kilowatts is conducted through a section of insulating material 0.6 meters squared in cross section and 2.5 cm thick and the thermal conductivity is 0.2 watts per meter squared degrees Celsius, compute the temperature difference across the material. Okay, so when we analyze this problem, we can visualize first what's happening. Ano? So sinabi dito, meron tayong insulating material. Pero the point is, hindi naman sinabi sa atin kung ano ba siya, slab, or baka pwede hollow cylinder or sphere or whatever. But may sinabi lang sa atin na siya ay insulating material. Okay? So, with that, since sinabi sa atin dito is further addition to the knowledge na siya insulating material, meron siyang cross-section na 0.6 meters squared. So, and a thickness of 2.5 centimeter. So, mangyayari lang dyan, if we have that kind of material, so we can just simply use the general formula, since kung mapapansin nyo, yung mga given natin is direct substitution from this formula. Okay? So, why is that so? Kasi, yun pong 3 kilowatts, sorry, nawala. Let's move it here. Okay? So, kung mapapansin nyo, kasi yung 3 kilowatts is, ito yung ating Q. Okay? So, 3 kilowatts siya, no? Pero, syempre, yung kilowatts na yon, since ang kilowatts is already in metric units, but we need to use the MKS. Okay? So, with that, let's convert this to watts. Okay, so we have 1 kilowatt and then 1000 watts. And remember, in your stoichiometry or calculations, watts is a unit for what? For joule per second. Okay, so 1 joule per second is 1 watt. So, by the way, so we have 3 kilowatts converted to watts and then divided by the area, which is 0.6 meter squared. Okay, so we don't have to convert it, which is equal to negative, and then K. So our K here would be 0.2, and it is already given in the correct unit. So, mapansin nyo, siya ay watts per meter squared degrees Celsius. Now, there are cases when the unit is given as watt per meter squared Kelvin. So, remember, we're talking about the change here, the change in temperature in terms of Kelvin and Celsius. So, remember, if we're talking about the change in Kelvin and then a change in Celsius, they are just the same. That's why we can interchange these signs or these units. Sorry. Okay, so with that, K, and then we have the temperature. So this is dt. In our previous derivation, we could say that dt is simply T2 minus T1, or simply the temperature gradient or the temperature difference. And with that, in this problem, we have compute the temperature difference across the material. So that is actually our missing variable. Okay, and then divided by our dx, and dx is simply our thickness, and that is x sub 2 minus x sub 1. So in this case, we can simply write 2.5 centimeter. And now remember, centimeter is not in MKS, so we need to convert this into appropriate unit. So with that, we have 100 centimeters and then 1 meter. Okay, and then so this cancels out, this one too. And now we could just simply solve for the value of this solution, and then we can now find dt, which is actually the temperature difference. So let's try solving this. Okay, so I'm back. So I know you're already familiar with how you do shift solve, but still I will do this for the sake of everyone in the group. Okay? So when using shift solve, you can simply type in what's written on the whiteboard or x, and then you'll find the value of x, which is the temperature difference. Hopefully you can see the answer, but it's negative 625. Okay, so the answer here is negative 625. So what is the unit? So if you want to be consistent with the unit, then you should be using this degree Celsius. But it also means that since degree Celsius is equivalent to the change in Kelvin, then you might as well want to use Kelvin, but you need to specify that this is a change. So yeah. Now let's have another problem in which we don't have a value for our thermal conductivity. So I will give you some time. Please pause the video para makapag internalize kayo ng problem, and then afterwards continue it so that we can now proceed with the solution of the problem. Okay, so I hope na naintindihan nyo na yung problem. So after understanding the problem, we can now at least draw the figure para mas ma-visualize natin kung ano ba yung nangyayari dun sa ating heat transfer. So let's just draw a slab, and this will be our wall. Okay, so syempre not to scale to, no? Kasi mamamali tayo if in-scale natin, no? But then the wall measures 5 meters in length. So in this case, this is 5 meters. And then the height daw is 3 meters. So that is 3 meters. Now, sabi dito, it is 18-inch thick. So ibig sabihin, this thickness here is 18 inches. Now, we have a temperature gradient of 115 degrees Fahrenheit and 63 degrees Fahrenheit. So, assume na lang natin na ang ating T1 is equal to 115 degree Fahrenheit, and then our T2 is 63 degrees Fahrenheit. Okay? And then, so, yun na yung mga importanteng given natin. And then, we just need to utilize the formula that we have. And remember, the Fourier Equation states that Q over the area, it is equal to negative K dt over dx. And then, integrating it further, this becomes Q over A is equal to negative K, and then T2 minus T1 divided by x sub 2 minus x sub 1. Then remember, this T2 minus T1 is our temperature gradient, or we can say that this is the delta T, and then x sub 2 minus x sub 1 is our thickness, which is the delta X. So with that, let's try solving for our heat rate, which is our Q. So the other thing that we need to find here is our thermal conductivity, and to do that, we need to evaluate our thermal conductivity dun sa mean temperature. Bakit ganon? Kasi thermal conductivity is dependent on our temperature. Okay? So, if, for example, yung ating thermal conductivity has of course, meron tayong side 1 dito and then side 2, it has a temperature gradient. So therefore, I need to evaluate yung thermal conductivity dun sa gitna ng temperature na to. But if ever meron tayong mismong equation or function in terms of T for our thermal conductivity, then we will substitute this equation to that expression na given yung ating K. But for now, since wala naman tayong ganong equation, then we need to use a table in the Paris handbook. So before anything else, let's just first find the average temperature first. So that is simply taking the mean of the two temperatures. So in that case, that is the average is simply equal to T2 plus T1 over 2, which is simply 63 plus 115 divided by 2. Our average temperature would be 89 degrees Fahrenheit. So we need to find the thermal conductivity at which the temperature is 89 degrees Fahrenheit. And remember, sabi ko nga kanina na ang ating thermal conductivity is dependent on our temperature. So for good conductors, meaning mga metals to, our thermal conductivity decreases as the temperature increases. So for metals, usually for metals, as the thermal conductivity increases, the temperature decreases. And then for our insulators, they behave differently, no? And it is the opposite behavior. So if the thermal conductivity increases, then the temperature should if the thermal conductivity if the thermal conductivity increases, then the temperature also increases. This is also true for gases. Okay, so in this case, we will have to find our values. And ano ba yung hahanapin natin na material? So based on the problem, if you have read it, we will be finding the thermal conductivity of our asbestos, which is the material na ginamit natin. And asbestos is considered to be an insulator. So expect natin na dun sa mas mataas na temperature, mas mataas yung kanyang thermal conductivity. Okay, with that, let's use our Paris handbook. So ang available ko lang ngayon is 8th edition kasi nga wala pang PDF file yung ating 9th edition. But I will just probably put somewhere here in the video kung saan natin makikita ang table siya using 9th edition. Okay, so let's take a look at our 9th edition. 8th edition. So this is the Paris handbook. So if you wanted to check on this book, you will see that at transport properties, which is at chapter 2-459, our table 2-32326. So tandaan nyo siya, no? This is the thermal conductivity of some buildings and insulating materials. So kung saan gawa yung mga buildings and insulating materials, dito siya makikita. Napakarami dyan. From aerogel to wood shavings. So, andyan. And then, of course, kailangan natin is asbestos. So, ito yung ating asbestos. Medyo marami siyang values kasi yung K natin is this one is the thermal conductivity in English units. Okay? So, with that, let's try finding which value that we will use. Okay? So, our mean temperature, remember, is 89 degrees Fahrenheit. But, this one is in degrees Celsius. So, we need to go back to the problem and then we need to convert our temperature first in terms of degrees Celsius para magamit natin siya dito during interpolation. Okay? So, with that, 89 degrees Fahrenheit, we need to convert it in degrees Celsius. So, 89 degrees Fahrenheit, if you have your calculator, you could just press shift, convert, and you can just use number 38, 37 to convert degrees Fahrenheit to degrees Celsius. Kasi this is supposedly a basic thing naman for engineers to convert. So, hindi ko na kanya-require na gawin nyo yun mano-mano. So, this is 31.6 degrees Celsius. Now, with that, we need to find the thermal conductivity at this temperature. So remember, you can use a shift, just press shift and then convert number 13 in your calculator. So with that, let's remember 31.666. So I will store this value so that I have an exact item. And then, so going back with that, so meron tayong madaling way para gawin ng interpolation. So balik natin sa screen dito, and then I'll just be writing it somewhere here para mas makita niyo yung kung paano ba nag-interpolate. So with that, let's try to go back with this. So we have x, 0, and 100, and then at 0 we have 0.087. Let's just use these values. So we will be using this for our x and y values. Okay, since nandun na yun sa gitna in mga values. And then, with that, click regression and then y hat, and then the temperature, which is 31.666. And with that, the answer based on our interpolation is 0.0946. So our K is equal to 0.0946, and then our unit is British thermal unit. Then British thermal unit per R feet squared multiplied with degree Fahrenheit feet. Okay, so that is BTU per feet degree Fahrenheit. Okay, kasi kung mapapansin nyo dito, it should be feet squared and then degree Fahrenheit over feet pa. Pero yun nga, since makakancel out itong 2 dito sa 1, so mangyayari dyan is matitira na lang is yung feet. Kaya pwede natin i-simplify yung ating unit in terms of BTU feet degree Fahrenheit, or simply BTU degree Fahrenheit feet. So whichever is mas madali sa inyong isulat. And then since we already have our K, and then T2 minus T1 meron na tayo, and then x sub 2 minus x sub 1, and then the area, so we just need to find our Q. But before anything else, since meron na tayo lahat nito, remember, our area is in terms of meters. And kung mapapansin nyo, lahat ng mga variables dito are in English units. So we still need to convert these meters into feet. Okay? So with that, you can just simply use your calculator, and I'll just be using the shift convert, and then we can convert it using meter to feet, which is number 4. So 1 meter is around 3.28 feet. So you just simply multiply it, or if kasi ako I want it to be as exact as possible, so I use the conversion function in the calculator. So that is 5 meters to feet, so that is 16. 9.4042 feet. That is for 5 meters. And then 3 meters should be equal to 9.8425 feet. Okay. So with that, we already have all the values for our heat rate across the 18-inch thick flat, and we just need to substitute these values. Okay. So we have Q. So in terms of Q, our equation would be Q is equal to A times a negative A and then K T2 minus T1 all over x sub 2 minus x sub 1. So finally, we have Q. So we're talking about the area here nung wall natin. So this is just length times width. So therefore, our area is, remember, the answer is 16.4042. So that is 16.4042 feet times, we have 9.8425. So we have 9.8425 feet. And then we have here, let's just write the negative one here. Negative 0. Because I forgot to write it here. 0.0946 British thermal unit feet degree Fahrenheit. Then we have the difference in temperature, which is simply 115 and 63. So with that, we have 63 minus 115 divided by the thickness, which is 18 inches. So 18 inches should also be converted to in terms of foot or feet, since these are all already in feet. So we just need to divide this by 12 inches. Okay, so with that, let's cancel out all the unneeded units. This one, and then this one. Okay, so finally we have the answer, which is Q, and that is equal to so our heat rate is equal to 529.4972 British thermal unit. So that's it for our problem involving a thermal conductivity, in which we need to still locate the value that is not given in your problem. Okay, so you might as well want to check this if this is also your answer, and if not, then you might as well want to review all the processes, then baka nagkamali lang kayo along the way. Okay, so that's all for this thermal conductivity. I'll be having another problem regarding those thermal conductivities that are dependent on temperature. dependent on temperature in which it is given by a certain function with respect to the temperature. Okay, so thank you.